Hello and welcome back to another episode of Getting into Good Oxide. Welcome back, Sydney.
Hi, Sebastian.
And after a little hiatus of not making any episode because we're busy with other things that seem more important, like doing work tree checkouts real fast. Now we're back with Bergen and the open issues here, which isn't too much. Like technically it's really simple and small, I guess, but or maybe I'm describing that wrong, but I think it doesn't look like much, but it is quite a lot to implement. Yeah, like last time.
Exactly. One checkbox on the surface, but a lot of hidden checkboxes here.
Yes, a lot of subtasks. Well, maybe just one method or one function that takes as input. Yeah, what does it take? I guess we can get there when we get there. Just as a little reminder of what this is supposed to be. This is get describe, huh? Yeah, this. Which is a special syntax for find the closest tag and tell me how many commits my current commit or the given one is in the future of that tag. So it's always kind of as seen from the past into the future based on a certain amount of or a certain set of tags and or branches even. And -g means git, right? And then there is the shortest possible hash or short hash. I do have the feeling that I have something in my config that says abref5 because that seems very short. And that's more like it. So in my case, it gives me 8 hex chars, 4 bytes. Yeah, honestly, it can't be too hard.
It should be fine. Just a question, like the first part, the git 10 file, this is the current branch that you're on? Or what does that exactly mean?
That's the closest tag in the past.
Oh, so this is the name of the tag, basically. All right.
Yeah.
Okay.
Yeah, let's put that to the test here. Down. And it's pretty far in the past, true.
Mm-hmm.
So 187 commits ago, I published something. In this case, it's always a bit odd, in Git Oxide, because there's these name tags that refer to crates, and it's not really Git Oxide. So it's one way of naming things, but it's probably better in other projects that really only have tags for versions, and that's it.
Mm-hmm.
But ultimately, if you would be able to tell Git only to use these top level version thingies, then then it probably is much more like what you would want to see. And maybe you can even do that with some arguments and flags and so on, but yeah, with what we built, I guess that can be done more easily because just a method call or a function, I guess. Probably a function. All right, then, yeah, how would you approach it? We are on a blank slate here.
Slates. So yeah, we need to somehow look through the history, right, and check for these tags or tag objects. And
yeah,
I guess my question would be, what's the best place to actually put this in? Like, where will this be implemented? Is this directly in Git repository?
Ultimately, yes.
Mm-hmm.
But you know how it is. It always trickles up from these plumbing crates. And back to your question, yes, there should be some crate here that should deal with these revision-specific things, like parsing revision names and producing revision names.
Like Git revision, maybe.
Yeah, maybe that. once it became clear what nameRev, like how git nameRev and git describe relate to each other, then I thought, yeah, this must be, it's all revision specific stuff. It's there must be some crate for that, and here it is.
Yeah. Okay, makes sense. So it's specifically for this task.
Yes.
We have a new crate.
Yes, I love these small crates. And honestly, like you could say, is this over engineering? Like, is there any benefit of having these small crates? Or do you just do it because it's cool to have more crates? And that's a fair question, really. Like, where's the value in that, right? And like, do you know the value? Would you be able to say it, or would you also say it's just nice?
I mean, I'm guessing beyond it being just nice and organized, you have a very nice way of thinking about it, right? It's very modular, and it's nice to structure it that way, and potentially it can be used for other things as well. Like it's not tailored to one use case ideally, but it's modular.
Yeah, so as value, the modularization, so that you're able to focus on one particular thing, and it's not just all one hodgepodge of stuff, which is usually a good thing, huh? Organization in source code, I agree. But you can also do this as a module, right? Like we can just have a bunch of modules here. We could have top level source, and then a bunch of library related modules, and you just pull in everything. And you could reorganize this, and Git Oxide becomes one very big library that also has binaries and all kinds of things attached to it. But beyond modularization, there is the huge value of having your own cargo manifest. And that is not the right one. That looked a bit crowded for a new crate. And this means you can have your own set of dependencies. And think about it, if you would have all the Git crates that there are right now in one manifest, then all their dependencies are just mixed together, and you can't unmix them anymore. And if you wanted to unmix them, then you would have to use feature toggles, and that complicates things a lot, and it's just not nice to work with. So ideally, I modularize code so that potentially I start out with 0 dependencies, and maybe one day just add the dependencies I need, which also keeps the compile times down to what it needs to be, which is really beneficial for your iteration times, as it's really fast to build. And it's really noticeable. Small crates, like they start out small and up to like 10-15 kilobytes of code. They're really, really fast in compiling. Also depends on dependencies, by the way, but usually as they grow, it becomes slower, and that is noticeable. Yeah. So I like to start a new crate often, especially when there's a nice theme for them. Interesting. Painting with...
Oh, you see that too, okay.
Yeah. Painting with boxes. It's like in Windows, right? When there was this... when it was hanging or something, then you could paint the frame buffer directly with your windows. And this is also the same principle, I guess.
It's these little hidden mini games to keep you excited and engaged.
Yes. Apparently it's doing its own drawing here. And yeah, an empty crate. That's always a bit of a hassle too, because you kind of start from scratch and start copying things over, or just redo everything. Maybe it's not a bad thing to just start over and see what's needed. Yeah, then, I mean, what's next? Now that we know what crate to use, what would you do next? What's your intuition? What's your thoughts?
Yeah, I guess I would start from the outside, trying to work inside. Like start with the top level function, maybe, literally calling it describe, and then trying to figure out what we need and where to go from there, basically.
To do. Okay. Forbid unsafe code, Rust 2018 idioms. Good starting point. we don't have to bother with, so we don't have it for deny missing docs yet. This means we don't have to bother with docs at all. That's usually how I start the crates, so that you really can focus on what matters. And once you want to publish the crate for the first time, you make sure that you add deny missing docs, and then you can work on writing everything that needs to be written. And
makes sense.
That's something I really love about that workflow here. It's just what you need when you need it. And that's a major difference, I think, compared to certain other ways of working where you have this whole set of good stuff that you want once a project is mature, but you use it from the very beginning, which slows you down because there's so much stuff you have to do, and then it detracts you from what you actually want to do and find out. And, just go back and forth. It's harder when you have to write docs right away and stuff like that. So it's fantastic to mix and match and just upgrade it as you go, which kind of makes sense too. But I've seen it often enough that you have to do everything by the book, so to say, from the very beginning, out of fear to, I don't know, never do it, Then let's run the tests. There should be none. Good work tree. Duplicate this one. Wow. How many characters do I see? 3, 2.5. Good revision. Test. Oh yeah, and we want the package being good revision. And there we go. No tests were found. True that. Yeah. So if you want to be really, really agile, you can in fact just do this tmod and start testing, right? Foo. And we're done, ready to go for the first test. And somehow I'm hesitant to do that, but maybe we should just do that and then be driven by actual need to move elsewhere. So why not? Okay, foo, first test. Now, yeah, what do we need to do anything really? We need a repository. And
yeah, true. Of course, to start testing out.
Yeah, or do we? Yeah, do we or do we not? We need a graph. We need a graph like this that we can traverse. And maybe we can completely abstract that away. And I think if we knew how you figure out what we want to figure out here, then we can see if a simple traversal can work with that or not. Like, what I'm wondering is, if there is branching going on, how does that affect? Like, how does branching ever affect the distance to a tag? Yeah, we can try that out, because I want to know if it's possible to do the right thing by, let's say, just having an iterator that spits out commits. Or hashes for that matter, because then we don't need anything. Then we don't need a real graph here. Then we don't need a real repository. So maybe
this is just counting commits, basically.
Yeah, maybe it can. So to figure that out, I would just create a tag here at this commit for testing purposes. Git tag testing. Tell me. Okay, and now the describe should find that because it's closer. I thought.
That's the thing, right? It only finds tag objects by default. So you have to give it the tag
Ah,
flag, right?
oh, good catch. See, that's confusing to me. To me, that's a normal tag, but yes,
Yeah.
it wants tag objects. Jeez.
That is confusing. I don't know if
Yeah.
there's a reason to do it that way.
I think for kernel developers, tags are not real unless they're annotated and signed and stuff. But for everybody else, a tag is really just a reference that has no object associated with it except for the one it points to. Yeah. It's made by kernel developers for kernel developers, and the rest of the world happens to use it too, you know? And that's fair, it's fair. But this also means that things like Git Oxide have to exist so that it can be a Git for the normal human developer being, you know? Which means kernel developers are beyond that, the godlike beings that they must be to write the kernel. So 138, it's still very far away here. Let's just check out this one, then we're a bit closer. You can maybe see what it would say. I would expect 1, 2, 3, 4, 5, 6, 7, 8, 9. If I check this one out, should be 9, huh? It's 15. Huh? How can it be 15? 1, 2, 3, 4, 5, 6, 7, 8, 9.
Definitely not 15.
How can it be 15? 10, 11, 9, 10, 11, 12, 13, 14, 15. So there are 15 here if I count these somehow. But I wouldn't know. So what if I count differently? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Huh. Yeah, you know what you see here? Coincidentally, it's an iterator, it's an iteration that Git reflog might do. It's a typical topological graph iteration, I think. So here you have two parents, and then you first use parent 1, you traverse this one till you find the next.
Okay.
And then you push this on top of a queue, and then continue down the second option that you had here.
Mm-hmm.
And then you find this after 15 items. But that's not the right way to do it, right? I mean, it's not correct technically. If I look 15 into the future, like, what is this good for if it's like this? It's not actually precise. Like, nobody would find this that way. You would find the wrong one. Like, the good thing is implementing it like this is easy because we can just use an iterator that spits out a flat list of items, and then we just check, hey, is that commit that I see now from my iteration, is that matching one of the tags that I know of? And if so, you found your baseline. And then that's that. It's nice. Because the baseline implementation of this, it really does, it's a couple of lines of code, I guess.
The functionality already exists.
Yeah. And this also means we can completely abstract this. And we don't need a repository for that.
Okay.
Because, I mean, now we have proven, right? Like, I really need you to check my sanity here. That I'm not crazy and maybe don't know or I'm hallucinating. But we saw what we saw. It's 15, and it makes sense if you do the traversal like you did. Like, yeah, and that's that.
Yeah, I guess I'm still trying to understand what this means specifically for the commits when you merge them basically, and how it would make sense to count them. Because it's basically, yeah, this topological approach versus like sequential, right? Just time based, I guess.
Yeah. So time-based means sorted in Git speak, and Git traversal can be sorted. What happens then? Let's see. We have 26. Here we have 4, 24, 224. So these are newer. These are technically, I don't know why TIG shows them that way. I think there's a lot of work to be done in displaying these graphs so that they make sense. I am going to write, oh man, flies. I should close something here. Yeah. What was I about to say? Yes, it's hard to properly display these graphs, and I would expect this to be on top. If you imagine this to be on top, then first it would see the left side, finds the next branch, which happens to be here, and then it continues traversing the right side, and this is how it gets 15. But that's exactly a typical graph traversal. I think we can even try that. If we could do a git log, how does that look like? Interesting. Git log sees the tag early here. See, if git log would be the basis of this, then you would have a 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Maybe because this is not sorted. I actually don't know what git log can do. Not at all. Okay. Still testing. Delmi is first. Is there something super easy? Follow, decorate, source, path, since until. I just want to see if there's a way we can use git, git log is a way to traverse the graph in all kinds of ways. And I was thinking if there's a way to make it traverse exactly like what we see here, so that it kind of gives us the 15 commits in front of the Delmi, which it should if it sorts by date somehow. No walk, only show the given commits. Do walk, sorted. Is this now? Is this still? Looks like 9. All right. Submit no walk, sorted. Then it doesn't walk at all. Is there a way to do something with the date? Filtering by date. But yeah. Git rev list. Maybe rev list is the thing that you're actually looking for. Ah, topo order. And it doesn't page automatically. It's that plumbing, yeah. That tells you you're playing playing with powers that you probably can't control. So we're looking for 591B53. B593. No. 591B. Look. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's still kind of 9, right? It's still close.
9.
But topo order should be the other thing. Should be the other way around. Should be 15. Unless it's sorted somehow. Maybe date order. Let's go date order. Must be that then, right? Even though I would expect it to be something else. Three. No, wait. 591. Okay, I don't get it. You know, it seems to be a dead end. Let's see what Git would do here. I just want to see what kind of traversal it does, because we tried to figure out if we really need a full repository or not. Because if Git doesn't do it like this, I would start out with doing it exactly like Git does. And if it's simple and easy and not complicated, then this would be nice. And I would be happy to do that. So. How does it do traversals? Finish depth computation. Oh, look. When looking at this, I don't feel like it's going to be that simple anymore. And the scene commits, look here. Here it returns this. Maybe that's where the depth is coming from. But that's the scribe commit here. I think that's exactly the function that does all the work. Gave up on commit list insert by it. So it looks like it's more complicated than just what I thought it would be. And I don't see, you know, I would have hoped that there's some sort of sign of traversal, something that is obviously a traversal or some iteration of sort, but it's, yeah, it's more list and all matches, or the first match. That somehow figures out what the best commit is. Maybe what we saw here is just a, yeah, maybe it's really a bug and it should be better, but maybe it's purely intentional. Even though I can't imagine that, because that really should be 9. Okay. So then, you know, like we are trying to find out how it's supposed to work, how it's supposed to tick, so that we can ideally implement it equivalently. And sometimes Git will just re-implement certain things that are implemented elsewhere. So maybe this is just a reimplementation of a topological ref walk, and it's just not so obvious when you look at the code. Maybe. Maybe it's more. Because it seems to be just commit list insert by date. Ah, wow, okay. I was about to say this just operates on a list here, but it also changes the list as it traverses it and pushes things back on. And this is probably where it gets its kind of topological sorting going on in the way it does it. So we have a list of candidate commits to start on. Get the parents. And then if you didn't see it, we put that parent on the list so that we will traverse it next. And this is, I think, why we see this 15 there. Huh. Let's see. I don't know, how do I print a number and see? Yeah, maybe. Maybe yes, maybe no. Maybe L for long. Int number. D. Status. D and S. Oh look, timestamp. Yeah, let's try D. D number. Okay. Why does that take so long? What? Make, what are you doing? Oh, it really just took so long. Okay. Let's quickly build Git here. And fix accidental changes. Is this a thing? It is. So now we should see that number. Git describe head. Ooh. Oops, it does something. So
Definitely does.
First attempt to write C, sec fault. Okay, C commits is a number, so maybe try to say it's a string. It seems wrong, but yep. Okay, it's not D. It's not S. Jeez, look, but it is D.
It should be D, yeah.
So maybe I have to use this internationalization thing to get formatting. Maybe. Oh no, wait. This internationalization thing here is actually just a string, not the argument, so that should be fine. Okay. So is it really crashing because I tried to print a warning here, or is it just generally crashing because of some other issues? All right. I mean, there's the reason I can't do C, right? It's not. Yeah. there a description of what you can do? Is a look here, as and D. Am I not getting it? Like this. Ah, right. I was passing not a string, but a character. And it allowed me to pass this, which is not even a thing, right? This is a character, this is a char.
Yeah.
Or is that? Is that a difference in C? I don't know. Maybe. I think it is. So how can I specify a char with 2 characters in it? Okay, so that should work now. Okay. But there's the answer. It tells us 0. And it still tells us 0. So that doesn't do anything. Okay. Okay. Let's start from the beginning, which I hope is here. Tags. Where does it use this? Describe commit. You know, there must be some code somewhere that then serializes it again so that you produce the string. So where is this? Append name. Here I think you get the name of the tag. Append suffix. Here's the depth. All matches depth. This is, yeah, this is it. Exactly it. So the depth of the best match, and somehow it's 15 here. Possible tag. Okay. I still don't know how it figures out that this has a depth of 15. Maybe that's about debugging Git now, or at least understanding why it would do that. The last thing I can imagine doing, trying to find out what's happening here, is to maybe do exactly that again. So where's the describe? Here, right? So if you print a warning in a way that it doesn't like, to crash it, you know, and then run the test, which test crash, and then you would be able to see kind of what the tests are, what the test expectations are, how they do testing. Oh. How did I run the tests? The thing is, I knew that once and was really trivial. I think it was just make test. Yeah, that. No, lot should fail. There's more than 2,000 tests, and that actually takes a while. And interleaving these tests like that, it's also not super awesome. But I'm just interested in failing tests after all, just to see which ones of these many files are related to Git describe. Maybe you can also just grab it git describe, and then focus on files to include only on these. So maybe that's another way of doing it. That is a bit faster in this case. I would hope that there's a bunch of tests that, oh look, describe, that say what it actually wants and what the expectations are. Abbreviations. Dirty working tree. Dirty head. Check describe. That's also interesting here. Where's that defined? So it's probably the expected output. I just don't know where it's I just don't know where that is defined here, because that repository apparently has some state already. Lightweight seems to be. Ah yeah. So maybe that's the one. That's where it's defined. I would expect them to somehow make a more complicated history at some point, because they have such complex code to traverse the history. Must be some reason, right? Like, where is that? Okay, I think this can. Oh, that already stopped. It's also hard to see what failed now. There's usually the failed tests. I thought they're usually collected here and you see their outputs, but you probably have to pass some flag to do that. It's nicely described what it can do here somewhere. There is a file for that. There's a README for that, but I always forget. It's not bad though, really. It's just something you have to learn just a little bit, and then you can do everything you would want to do. It's pretty neat. Nonetheless, here some complex. Ah, look. Here they do build some. Here they build some repository with 8,000 commits or so, in order to validate that their traversal, their topo traversal, isn't stack driven, but works without the stack, so that you can traverse any kind of depth. And just added 2 years ago. Amazing. It's more like if you didn't find any candidate within 8,000 commits, maybe previously it did crash because there was some implementation detail that was using recursion. Yeah. Interesting. But still, I don't see a complex topology here. Oh, now we're talking.
Yeah.
Finally. So I think this this is the kind of test we're looking for. From line 450 here. And look how they use this kind of, description. This is also part of Git revision, by the way. That's what nameRef does, I think. And this ref spec, this revision specification, they use to define exactly which commit they mean so that they don't have to name it by hash, which is pretty cool. But it's hard for me to see what the actual, this is nameRef, right? This is not describe. So, yeah, okay, I get it. Here, that's the expectation. So this is now a test for nameRef and not describe anymore. Yeah, there. Okay. So all this is very cool and nice. Check describe. Ah, look, here, now it's describe again. And here as well. I wonder if they draw these things by hand here, or have some tool to do it. Don't board too early when searching. Okay, so I think even though this is nameRef, and there's also nameRef, and nameRef is an entirely different algorithm, I think we see that it's not as simple as having some flat traversal from looking at the code and from looking at this. Let's see if this can be understood. So here we go into a disjoint. We initialize a repository in disjoint. We go in, make a commit, and make another commit that we tag with A, okay, and then another commit. So we are here. And then we check out an orphan branch. Jeez, do you understand this?
Not necessarily.
So, I mean, you can follow this A, O, and that must be X then. And then comes B as the commit B. I just don't know what. An orphan branch is an orphan branch. An orphan branch has no parents, I thought. And then we create a new commit that has this. Yeah. That seems to.
So yeah, it has something to do with the fact that it's a different branch and that it doesn't have a shared history, basically.
And then I think this merge here is also something that probably does some interesting stuff. You know what? I mean, geez, Why didn't I get this before? I don't want that in my history, so that's why. Okay, fine. It's the other way around, huh? It's kind of this inverted. Fine, you start here. And now Git described as what? A3G. A3G hash. Okay. Does that make sense? We're here. 1, 2. You know, I think I don't understand Git describe. Because if I count, it's different. 1, 2, 2 to the next one. Or 1 to the next one. We find A, right? A3 we find. A is the one that is closest. But 1, 2, you know, maybe 1, 2, 3, maybe I have to count it like this. Maybe count this as 1, 1, 2. I spent so much time testing this. I mean, not so much. I mean, there's only a few cases, but there's so much code in this way, in the way it does things. And yet I have trouble even understanding why 3 is a good number here. Because I think 2 is the better number. And then it's how do you implement something that you don't understand? Yet.
Maybe has something to do with the way that this is merged, basically. So the point where you are at after the merge consists of both branches, and that's why you do have to count both sides of the incoming branches and not just the one. Like it's a union of both branches. That's why you count both sides, not just down one branch. It's just a guess, but that seems like what they're doing, right? They're counting both sides instead of just the shortest path.
And our example here shows that even nicer, a bit more convoluted, but it's definitely counting both sides. Counts 1, 2, 3, 4, 5, 6, 7, 8, 9, plus 5 or 6, and then we have 15. Okay. So this means we have to see the topology. Have to get a real tree here, which also means for the tests. And now we are back to where we originally came from. We need a proper test setup, yeah. Some script that sets up a history. Because we will probably have to traverse it. And then you can probably just traverse it the way Git does for more or less the exact outcome or the exact result. Interesting. Okay. So maybe we can quickly get to the point where we can actually do this. I know no better but to basically take the setup from here. No, what? Nope. Don't do that. So we have tests. Jeez, it's very finicky. It wants to move things all the time. Rust file, revision.rs. Yeah, this probably isn't needed then. Revision. Then it's always a good thing to have the test tools from here for now. And then you can start making first assertions. I think it's fair to have a module that is called describe because we're going to have a lot of different tests with different setups, even though we just call one function essentially. Git describe. It names the ref, the described commit is on. So just as a test that I know should be simple to implement, and then we can kind of up the difficulty as we move along and kind of understand better with every stage what this is supposed to be really. And can use a bunch of tests that we have from the Git test suite to validate that we kind of find the same results in these cases that seem to be important to them. And I really like your summary of it, like count all the sides of a merge situation there, which we definitely want to have a test for as well. Okay, then Git test tools, scripted fixture repo read only. That's the thing we usually start calling, and then we have make, yeah, whatever it is that we want to make repo as some sort of default repo. What's this?
Oh, I see. Okay.
Does that need the fixture pass or something? I don't think so. Yeah, it does that itself. Okay, something like that. And then we get just a path to the repository that we can then use. Okay, and now if you run this, we have our first failing test for sure, because it can't find that file that I just specified here. And yeah, before it gets really loud here, let's just say this is where we continue next week. And it's going to be fun.
It was a lot of exploration, but I think it was necessary. Yeah. Next time we could start putting down some more tests and start getting stuff done.
Yes, that exploration was definitely necessary, and there will be more of that. I can't wait to stare at that C code to understand what it's accomplishing there, but it's all doable. So I guess we have to go through that until there's the pure understanding of what it really is supposed to be. And then you can just, that's the fun time. Then you can just implement it the way you would want to implement it without having to look at other implementations code too much. That might be hard to understand. But yeah, that's that. Thanks a lot for watching, and see you next time. Bye-bye.
Bye-bye.